So I am going to talk about the interactions stations. So this is the wrap up for that. And so we're going to go through kind of each of the stations. So for stations 1 and 2, you had the air puck, and you were asked to change the motion of the air puck, either start it moving from a stop, or stop it from moving, or have it move in a curve or swerve out of its straight path. And what is the only way you can get the puck to change its motion? So the only way you can get it to change its motion is if you physically touch it. Otherwise, it's going to have the motion that it has, either at a stop or moving in a straight line at a constant velocity. Okay, and number 3, for this station, you had an inflated balloon and bottle, and they were both attached to the string track. And when you let go of each, the balloon moved really quickly as all the air went out of it, and the bottle just stayed there. And so the question is, why did the balloon move? So you actually had something of a complex interaction going on, that the balloon was expanded. And so it had some elastic force. And the elastic force, because it was expanded, it was pushing against the air molecules that were inside the balloon and pushing them out. So the balloon, the elastic balloon, was interacting with the air molecules in the balloon and pushing them out. So then the air molecules in the balloon, as they were being pushed out, they were being pushed against the air molecules outside of the balloon, just at the opening of the balloon, and those air molecules were pushing back. And so basically it was the air molecules outside of the balloon that were pushing back on the air molecules inside of the balloon, and that was what was pushing the balloon forward. A little bit more complex than that, but we'll talk about it. So the bottle had an opening just like the balloon, and it had air inside of it just like the balloon, but there was no elastic force with the bottle. And so it was not pushing the air molecules inside the bottle out. And so there was no push out on the air particles. And so the air particles outside the bottle were not pushing back against it. So the elastic force of the balloon is basically what was causing the balloon to move fast. A little bit more complex, but that was close enough. Bottle, not elastic, didn't move. Okay, can you? So for this station, you were directed to move an aluminum can by not touching it with a balloon. And remember, we rubbed the balloon against our sweater or shirt or whatever you had to get it electrostatically charged. And with that, you were able to, so with the balloon that had static electricity on it, you were able to get the can to come towards you only, not able to push it away. And sadly, we will not study that this year. But the balloon had an electrostatic charge on it or static electricity on it, and we were able to pull the can towards us without actually touching it. So how come we were able to move the can without touching it, but not the air puck? And doesn't have anything to do with the mass difference. It's just because of the static electricity on the balloon. Number 5 was magic magnets. So for this station, you were directed to move a magnet with a second magnet without touching the 2 magnets to each other. And for this one, you were able to both push the magnet away as well as pull it towards you. So again, why were we able to make the magnets move without touching them, but we could not make the air puck move without touching it? Again, doesn't have anything to do with the mass difference. Magnets. Drawful. Okay, so for this one, you were making a picture of the sun, moon, earth system, and with the idea that the moon and the earth move in circles. Okay, the moon and the earth move in circles. So why does the Earth move in a circle around the sun without anything touching it, but we couldn't get the air puck to move in a circle without touching it, or we couldn't get the steel bearing to move in a circle without touching it? That was the one with the pi tin. Why does the moon move in a circle around the Earth without anything touching it? Okay. So, all right. So after you did the stations, you were instructed to divide them into two categories of interactions and provide rules for the interactions. And here's how I divided them. The air pucks, the balloon and bottle race, and floating clay challenge. That was where you shaped the clay so it would float in the container of water. So that was one class of interactions. And the other one was I can you, magic magnets, and drawful. So these are the accepted categories of interactions. What rules do you think apply to each one? So the way that they are generally divided is the ones on the left are called contact forces. And remember, forces, interactions, you have to have two bodies. So contact forces, you literally have to have objects touching each other. So for the air pucks, I had to physically touch it. For the balloon and bottle race, the air particles had to actually touch each other. The balloon had to touch the air particles inside of it. The floating clay challenge, the water had to touch the clay in order to be able to float it. Okay, so contact forces, you had to have contact between the particles. All right, the other type of interaction are sometimes called long-range forces, but another way to think of them are field forces, because these all involve fields where contact is not necessary. And so with I can you, that actually involved an electric field. The magnets involved a magnetic field, and the sun, moon, earth, that involved a gravitational field.